So my last video got cut off right at the end, but when we do 60 divided by 6, we end up getting y equals 10, and it asked us to find y, so that would be our answer. So that's the finished product of that question. Okay, so now let's add some theorems into our notes. So again, pause the video and your reflexive property. You guys are you have seen this before, but it was property of equality, and now we have property of congruence. So if you guys remember from our proofs, we would write reflexive POE, if you guys remember that. But now it's not POE anymore. It's going to be POC because it's congruent. So how do you know when you're congruent and when do you use the E and when do you use the C? The E is when you have an equal sign. The C is when you have a congruent sign. So notice on all of these, reflexive property says triangle ABC is congruent to triangle ABC. Symmetric property, if triangle ABC is congruent to DEF, then you can switch it, and DEF is congruent to ABC. And then your transitive property as well, but again, notice we have congruence. So that's how I know that it's POC for these three and not POE. So pause this and make sure you get that in your notes. The next theorem is our third angles theorem, and we know that all angles of a triangle add up to 180 degrees. That's something that we already know. So if I know that two angles are congruent to each other in these two, doesn't it make sense that this third angle will also be congruent because they always add up to 180 degrees? So that's what this third angles theorem tells us. If we know two angles of one triangle are congruent to two angles of another triangle, then we know that that third angle is also congruent. And again, pause that video and make sure you get this in your notes because you will use these in proofs. So now let's apply our proof here. So it says find the measure of BDC. Well, these two triangles are sitting on top of each other. So my first suggestion would be to redraw them so they're not on top of each other. So it's a little bit easier to see. So we have ACD, and then we also have, this isn't very good drawing, but B and D and C. And we know that A and B, they both have one arc, which means they're the same. So since this one is 45, then I know that that is 45. And then angle C. So notice here we have this angle C has two arcs, and this angle D has two arcs. So that means that this one is congruent to this one. And we know that this is 30, so that means that this one must also be 30. And we are asked to find the angle BDC. So BDC is this angle right here. We're trying to find this angle. But because I know that this is 30 and this is 45, I can just subtract that from 180. So 180 minus 45 minus 30. And when we calculate that, 180 minus 75 essentially gives us 105. So that measure of angle BDC, so we're going to write it, the measure of angle BDC is equal to 105 degrees. And we know that because we used our fact that the three angles add up to 180 degrees. And then if I said to find the measure of angle ACD, this one right here, because we know these two angles are congruent, don't we know that these two angles are congruent by that third angles theorem? So then without doing any work, I know that this angle right here is also going to be 105 degrees. And that is our third angles theorem and the end of our section 5.2.